Hey guys, Mrs. Tran-Bloom here. I am taking over for 6.4 notes. Our title for today is Solving Exponential Equations with Logarithms. Exponential equations that cannot be written as the same base are a little bit more difficult and will require a calculator. So can you guys do me a favor and pause and go get your calculator, okay? Now, as you guys remember already, if we have an exponential with a base b raised to an exponent of x equals a, now that can be rewritten as an equivalent logarithmic expression or equation with log base b. Remember, the base here in exponential, it's always identical with the base in log. So log base b of a equals x. So here are the three guidelines. Please copy this down. Step number one, very similar to what you guys have seen before. Isolate the base. That means you want to get it alone. Step number two, write in logarithmic form. Step number three, solve. And I hope you guys remember the change of base formula. So use change over base formula. All right, so the change of base formula was if I give you guys log base b of a, we can rewrite that as log a divided by log b. If you guys do not see any base written in a log, remember it's always log base 10, all right? Now most calculators are made for log base 10. Let's complete examples 1 to 5. Solve, that's all, okay? Now here it doesn't state how many decimal places that we want you guys to round to. So we're gonna round to, can you add this on please? Round to 4 decimal places, okay? All right, here we go. 1, 4 raised to the x equals 24. Now the base is 4, the base is 4 and it's already isolated. I mean, it's all by itself. So now we are going to write it in logarithmic form. So we will start with the log, and the base in exponential is 4, so the base in log is also 4. Now we're going to write of 24. So remember, the base is always below, right? Every single thing else, and then equals to x. Now we are going to use the change of base. So log of 24 divided by log of 4 equals x. Now this is, for right now, the exact answer. I can show you how to simplify a little bit more, but for now, that's the exact answer that we want you to have. If we said exact form, that's what I want you to write down. Now go ahead and take out your calculator. I'll pull up my calculator that's already here. So as you can see, I have a log button here. Some calculators does log and then you enter 24 first. Now my calculator, I have to enter 24 and then hit log. Can you do me a favor and make sure you have your calculator and know how to use that button, okay? Then I'm gonna go divided by, and again, my calculator requires me to enter the button first and then log. You need to test out your calculator to see what your calculator requires you to do. I'm gonna go, okay, well, 4 logs. I mean, it's, if you look at the top here, it says log 24 divided log of 4, and then I have to hit enter still. And then that will give me 2.2925 because I'm rounding it to the nearest 4 decimal places. So I gotta go back and enter that in. So exact form, now rounded form, 2.2925, okay? So I want you to take your calculator. Your calculator is only going to be helpful to you if you know how to use it. Let's do similarly to example number number 2. So first, as you can see, is 7 raised to the nth equals 20. The base is already by itself. Can you do me a favor and write it in log form? Okay, hopefully you have log base 7 of 20 equals x. And again, remember, I want to see your base below all of these things, okay? Now we are going to use change of base. So log of 20 divided by log of 7. Leave it like that. That is the exact form using the change of base. Now go ahead and take out your calculator, guys, and give me the rounded 4 decimal places, all right? Rounded answer. Hopefully you got 1.5395. If you know how to use your calculator and the change of base, is that easy for these first 2. Now example 3 and 4, as you can see, we have a bit more things to do. So the first thing I want to do is isolate your base. So move the 3. 59 divided by 3, that's going to give us a 56. Yep, go ahead and write that down, please. Okay, so the base is 7. We will start with the word log, and that would still have the same base here. And log base 7 of 56 equals to x minus 2. Okay. Now again, we are going to use the change of base and move the 2 over at the same time. So log of 56 divided by log of 7. Then we're going to move the 2 over to the left by adding 2 to both sides. So this would be your exact form. Now technically, I can simplify this a little bit more inexact. So log of 56, y'all, is really, well, 56 is 8 times 7, right? So 8 times 7, like that. Then we have the denominator being log of 7. And then I'm just going to copy everything else down. Oops, equals x. Well, you guys remember the last unit, when we have multiplication in log, it actually, we can rewrite it as an addition in log, okay, just like this. Then if that's the case, well, we have the denominator of 7. That means we can separate it like this. And everything else, I'm just copying this out. Well, log of 7 divided by log of 7, that's just simply 1, okay? So we're going to go log of 8 divided by log of 7, that's 1. Oops, I'm sorry, this is plus 2 equals x. So plus 2 plus 1 here. Okay, so honestly, I can simplify all the way here by hand. So this is the exact answer. This or that we will take if you want when we ask for exact answer. Now go out and take your calculator for me, and you can use either one. Oops, and I forgot log 7. Ooh, I keep forgetting that. Okay, either exact answer. Punch it in, round it to 4 decimal places, and let me know what you end up with. Hopefully you guys got x equals 4.0686. All right, guys, let's move on to the next example. Okay, so for this one, I'm going to ask you to do me a favor, please, and just change this right here to 258, just like that, okay? All right, so follow the guidelines, isolate your base. So to isolate your base, you are going to subtract 18 from 258. So we got 4 times 1/5 to the power x minus 3 equals 240. Then divide both sides by 4. Now dividing both sides by 4 is the same exact operation as multiplying by a quarter. Okay, you can do either. So divide both sides by 4. So now we have, this is going to cancel. We have 1/5 raised to the power x minus 3 equals, the reason I want to change it to 258 because it's now a nice 60 like this. Okay. Now, as you can see, the base is 1/5. Okay. So we are going to use 1/5 to write it in log form. All right. Ready? Log base of 1/5 of 60 equals x minus 3. Now I'm also going to show you another way to go about this. Would you agree that 1/5 is really 5 to the negative 1 power, and we had x minus 3 that was still there? Now this is power to the powers here, so we are going to distribute your exponent. So that's going to be a negative x plus 3 equals 60. Now for this one, your base is 5, so log base 5 of 60 equals negative x plus 3. So we are going to solve both ways here. And as you can see, if you use your calculator and round it, you will get the exact same answer. So for the lighter blue method, I'm going to subtract 3 from both sides. But I am going to use the change of base here. So log 60 divided by log 5 minus 3 equals negative x. Last, I'm going to divide each and every term by a negative 1. Dividing each and every term by the negative 1 is the same thing as multiplying each and every term by negative 1, like that. So with that said, my exact answer would be negative log of 60 divided by log of 5 plus 3 equals x. This is the exact, okay? We will use a calculator to round it soon. Now over here with the darker blue, the change of base is log of 60 divided by log of 1/5, and then plus 3 equals x. So that's my exact over here, and technically we can do a bit more, but right now, now let's use your calculator. I want you to use a calculator and find the answer to both. Exactly, I want you to find the answer to both. Remember, I want you to round to 4 decimal places. Okay, so hopefully you got 0.4560 for both, okay? Now, in the case that you do not have the same exact answer, I want you to ask your teacher about how to use your calculator, because again, your calculator is going to be useful only if you know how to use it, okay? Okay, we got 2 more examples for these instructions. Let me see. Did the instructions say 1 to 5? Oh, can you fix that? Oh man, that should have said 1 to 6. All right. Okay, let's go to 5 and then 6. Okay, follow the same exact guidelines, y'all. First, isolate your base. So move the 2 over. So 523, take away 2, that's 521. So now we have 100 times e to the x minus 4. Next, divide both sides by 100. So e to the power of x minus 4 equals, well, 521, y'all, divided by 100. I love dividing by 10 or 100 because technically it's just really moving. It's kind of like just moving the decimal, right? Now, e is a special value, okay? So remember, your base is the same. So your base in this case is e. I'm going to write it as log base e of 5.21 equals to x minus 4. But no. We cannot keep log base e as log base e. Remember, log base e is a very special value. We change it to natural log. So natural log of 5.21 equals x minus 4. Natural log has its own button on your calculator. So the exact value for this one, students, I want you to leave it in the natural log form, okay? Do not leave your log base e as log base e ever. You must always change it to natural log. Now go ahead and use your calculator for me and punch in natural log of 5.21. add 4, and I want you to round it to 4 decimal places. Come out and write it right there. I'm going to come back to it later. All right. For this example, we are going to do exactly the same thing. Are you guys ready? Okay, so subtract 100 from 1,000. That will give us 900. So 2 to the 3x minus 4 equals 900. The base, it's all by its lonely self, which is exactly what we want. So the base is 2. So remember, the base in exponential, it's also the same base in log. So make sure you write log base 2. And just a reminder that base 2 must be below everything else. So log base 2 of 900 equals 3x minus 4. Now we do want to use the change of base and move over the 4 at the same time. So log of 900 divided by log 2, if we move the 4 over, that becomes an addition, and then that equals to 3x. Now we do want to isolate our x, so we want to get rid of the 3. Now we can divide each and every term by 3, or we can go in and multiply each and every term by a third. That's exactly the same, right guys? Okay, so we now have log of 900 divided by 3 times log of 2 plus 4 over 3 equals x. This is your exact form. Now, can you guys do me a calculator and punch it all in? Let me know what you come up with, because we do have to go back to example 5 and check your answer. Hopefully, your rounded answer is 4.6056. And let's go back to example 5 and enter that in. 4 decimal places. Did you get 5.650? 6, because we want it to round to 4 decimal places. Now, if you got a slightly different answer on 5, it's because you're not using the natural log, okay? Can you see under my log button here on the bottom left of the screen? I can't move up my calculator. I don't know why. Remember, my calculator requires me to enter in 5.21 first and then natural log. Okay, so that's what I got for the natural log of 5.21. And then I have to add 4, and I have to hit enter. So that's why it's 5.6506, because we're rounding it to 4 decimal places. Okay, we got 2 more to go, and then we are done. So this is example 7, guys, and do me a favor. That's not 9, that's going to be 8. Okay, so finding the x and y intercepts of our exponential functions. To find the x-intercept, set y equals to 0. Now, guys, this rule doesn't ever change, right? Doesn't matter what function we throw at you, that will never ever change. To find the y-intercept, set x equals to 0. All right, guys, let's rock and roll. So let's do x-intercept first. That means y will get 0. 0 equals 3 to the power of x minus 4 minus 1. This is solving just like the first 6 example that we just got done. We would add 1 over because our goal is to isolate your base, okay? Now that the base is isolated, we need to rewrite it as an exponential. Your base is 3, so in exponential, it will still be a base of 3. So log base 3 of 1 equals x minus 4. Now next, we want to add the 4 over. So to add the 4 over, we would have, and use a change of base, we would have log of 1 divided by log of 3 plus 4 equals x. Now let me tell you guys something. Log of 1, y'all, is 0. Now if you don't believe it, go back to your calculator and test it out. Okay, I'm going to clear it out. I'm going to put 1 first and then hit log. Whoa, it is totally 0. So the exact answer is 0 divided by anything is 0. So the exact answer would just be simply 4. Okay, so your x-intercept is 4, 0. Box that up. Now y-intercept, we will set x equals to 0. Y-intercept, it's usually slightly a little bit easier because all we have to do is plug in 0 for x. So 0 minus 4 is negative 4. So 3 to the negative 4 minus 1. Well, negative exponent, students, to make it positive, right? You guys remember this? We make it into a fraction and we bring it to the denominator, minus 1. Now 1 divided by 3 to the 4th, 3 to the 4th is 81. Okay, now minus 1, I'm going to make this into a common denominator of 81 over 81. So y-intercept is at the negative 80 over 81, and we want to write it as an ordered pair, so just like that. Oops, I meant negative 80 over 81. Voila. Okay. Last example of today. Very similarly, we will find x-intercept first by setting y equals to 0, right? So 0 equals 2 times 1/3 to the power of x plus 1 minus 6. Move a 6 over, so that's positive 6. And I'm just going to copy all of this over. Remember, our goal is to isolate your base. So next, divide both sides by 2. So that's 3 equals 1/3 to the power of x plus 1. I'm going to show you this 2 ways. Right now, I'm just going to keep the base as 1/3. So log base of 1/3 of 3 equals x plus 1. And over here, remember we did this prior with one of the questions above. I'm going to write base 1/3 into a 3 to the negative 1 power to an x plus 1. Now, remember we talked about power to the powers here. We are going to distribute. So 3 equals 3 to the negative x minus 1. So here I have a base of 3. So log base 3 of 3 equals negative x minus 1. We are going to solve for x, okay? And keep it as an exact. And then I'm going to ask you to see if it's possible, if need to, punch it in. But let's go from here. Well, log base 3 of 3. In the prior unit, we taught you guys logs, right? And log base 3 of 3, y'all, is 1. Yep. Log base 10 of 10 is 1. Log base 5 of 5 is 1. Log base x of x is 1. So 1 equals negative x minus 1. So from here, I'm going to add 1 to both sides. So this is 2 equals negative x. Divide both sides by negative y. Divide both sides by negative 1. X comes out to be negative 2. So your x-intercept is going to be negative 2, just comma 0. Now over here, we are going to write it as, again, change of base, okay? And I'm just going to move the 1 over right now. Well, 1/3, we can now rewrite this, okay, as log of 3 to the negative 1 power. Just like that. Well, in log, students, an exponent can be rewritten as a product. That means I'm going to move the negative 1 in the front and multiply that to log of 3. And again, I'm just going to copy the 1 down. I'm out of space over there, so I'm going to move over here. Well, as you can see, we have log of 3 divided by log of 3. That will give us 1 because they will end up canceling, okay? So now on the top, I have negative, on the top, I should have a positive. Divided by negative 1, and then we have this 1 still here. Well, negative 1 and a positive 1, that's a negative 1, minus 1 equals negative 2. Okay, so either way, guys, you're going to get the same answer. So your x-intercept is going to be negative 2, 0. Doesn't matter how you guys solve that one. Last one on this one is the y-intercept. We will set x equals to 0. Y equals 2 times 1/3 0 plus 1 is to the 1 power minus 6. So y equals 2. Well, 1/3 times 2 is, I'm just going to rewrite it as 2/3. I hope that's okay with you. Well, minus 6 is the same thing as 6 over 1, so I'm going to find the common denominator. That means LCD would be 3, so this is 3 and this is now 18. So 2 minus 18, that will give me a negative 16 over 3. So y-intercept is 0, negative 16 over 3. Box that up. And that's it, guys.